Our project is calculate flight information, weather, and flight CO2 emission estimation, and our team is Alyssa and Siri and Karun. Next, we will talk about Project Go and data pipeline. Project Go is to develop a data pipeline integrating data flight information from YYC Airport, covering hourly weather data and flight distance and carbon emission estimation. Data ingestion involves daily flight information from YYC Airport website via web scraping, alphabetically ITAT Airport code list from Wikipedia, covering weather and flight carbon emission estimation via API. Data transformation. Our strategy involves integrating flight information with the ITAT Airport list to enrich our dataset with additional details such as date, country, airport code, airport name, in addition to the flight schedule, status, number, gate, airline, and city. Data serving. We aim to generate insightful visualization from enriched Calgary flight dataset and weather, and flight CO2 emission estimation user interface to provide deeper insight into the flight data. As for the data storage, currently we use S3 bucket to store lookup table, flight data, and visualizations.
Moving on to the data collection, our project has three major data and taken from three different sources. The first and foremost flight data has been scraped using Selenium from the Calgary Airport Authority website. The snapshot of the website is given on the right hand side, and the cron job is being established on AWS just to scrap the daily data. The scrapped daily data is being stored in Amazon S3 bucket. Moving on to the weather data, this weather data has been taken from a weather API which has hourly weather data of every day. So this weather data is also been taken from the weather API using a cron job which will be running at 1 a.m. so that it could take the previous day weather in an accurate way. Then moving on to the carbon emission data, the scrap data from S3 will have the flight route, and from this flight route information, the from and to address will be given as the input parameters to the carbon emission API, and the API will return the appropriate figure for the carbon emission for that particular route. This captured emission data will be further processed or stored with the flight and weather data, and it is used for analysis in our project.
Next, I'm going to talk about data transformation. After we got the flight schedule from the web scraping, we merged the flight schedule with airport lookup table that we create. So we add ITAT airport code, airport name, and country to the flight schedule table. Then we can calculate the CO2 emission and distance by inputting the departing and destination city. One limitation is that the CO2 estimation API we have can only estimate in national airport in big city.
To visualize the data that we collected, we chose 5 different visualizations. 3 involved time delay from when the flight was scheduled to arrive or depart and when it actually did. These 3 are the box plot of time delay by airline, the histogram of time delays, and a scatter plot of ambient temperature versus time delay. The other 2 are a pie chart showing the number of international flights versus domestic flights, and the last is the distribution of scheduled times that flights were supposed to arrive or depart. I was a little disappointed in the scatter plot. However, this is only one day, and I'm curious to see what it looks like if several days were plotted. I also find the morning gap in the scheduled flights interesting. I always assumed that airports operated 24 hours. It would be interesting to see if this was just this one day or if this is actually a thing.
Let's move on to the data serving, which is the ultimate objective of any data project, and it involves providing users with accessible data in an easily understood format. So we created a publicly accessible Flask-based website for that purpose. Data and visualizations were retrieved from S3 storage using Flask. Nginx and GUnicorn were used to support website functionality for global accessibility. And as you can also see in the image right side, we extracted the images and CSV from the S3, and the information for the carbon emission was taken from the REST API. The website is accessible at the instance IP address, and the website is currently showing the images for April to 2024, whereas the expected performance is the date should be taken from the user and corresponding images should have been shown. And this is the CO2 emission calculation, which is just by default, which is just giving the default value and is not working as expected. So since we don't have enough time, I've created to direct to fully functional Streamlit site. Since our website was not fully functional, these are the future tasks we intend to do. First one is to implement a date selection feature for data filtering, and second one is to integrate weather information display on the website, and then set up departure and arrival schedules independently without the help of Streamlit, and validate start and end locations which we take as an input for the CO2 estimation, and then develop a live updating data visualization project. Thank you.